So today we're going to talk about properties of real numbers, and I'm going to give you an example of every single one of the properties that we have. And then at the end of the Ed puzzle, there's going to be a quiz. I don't feel like giving you an extra assignment on this because it's really more about understanding how these properties work within the terms of the real number system. So there won't be a lot of practice that goes on with it. It's more a general understanding of how the properties work. Now, first of all, it helps to know what a property is. And in math, uh, properties are just statements that are true for any numbers. So in math, properties are statements that are true for any numbers. Means you can apply it to all real numbers. Right? What they do is they justify steps when we're simplifying expressions or solving equations. They justify steps when we are simplifying and solving equations. And most of them we usually only discuss them in terms of addition and um, multiplication because there's really no reason to extend anything towards like subtraction or division because they're just opposites of addition, right? Subtraction is just adding of negative numbers. Division is the opposite of multiplication. It's the inverse of multiplication. So So we usually just focus on multiplication and addition, which makes this a little bit easier for us in terms of listing them all. And some of them you probably have heard before, but I would just like to kind of keep it as let's see if we could do some kind of a grid here. That's not going to work for me. Might make that go away. Go away. We'll start with our first property, which is the commutative property. Then we'll go to the main idea of that property. And then we'll do an example of each property. And we'll do an addition example and a multiplication example of each one. So the first property we're going to talk about is the commutative property. Commutative property, right? And that is in terms of addition and multiplication. Addition and multiplication. And the main idea behind that is that order of values doesn't matter. Does not matter. And what I mean by that is if I am adding A plus B, it is the same as if I add B plus A, right? Or if I'm multiplying A times B, it's the same as if I'm multiplying B times A, right? If we think of that in terms of actual numbers, we're saying that 2 plus 3 equals the same thing as 3 plus 2. Either way, we're going to get 5 out of it, right? 2 times 3 equals the same thing as 3 times 2, right? Either way, we're going to get 6 as a solution. And that's really all commutative means. It means any order that I put those in, my solution is going to be exactly the same. I'm going to have that same value. So the order doesn't matter in the value when I add and subtract or multiply and divide, right? Our next property we're going to talk about is the associative property. Associative property. And what that says, here we're talking about order of values doesn't matter. In this case, we're talking about grouping of values. Doesn't matter. Does not matter. Associative is about groups, associations, right? Does not matter. Associative, group. Commutative is order. Associative is grouping. And it's saying that it doesn't matter how I group things when I'm adding them. If I have A plus B plus C, right, it is going to be the same as if I have A plus B plus C. And in the same respect, if I have A times B times C, and I group this part, right, it's going to be the same as if I have A times B times C and I group these. And if you think about it, that makes some sense, right? If I have 1 plus 2 plus 3 and I group these together, I still get 3 plus 3, which is 6. And if I have 1 plus 2 plus 3 and I group these together, I still get 1 plus 5, which is 6, right? And the same is going to happen for multiplication, right? If I have 2 times 3 times 4, right? 2 times 3 times 4, right? If I multiply these, I have 6 times 4, and I still get 24. If I have 2 times 3 times 4, and I multiply these, I have 2 times 12, which is still 24. It doesn't change the value if I group them differently. And that's what associative means. Identity is our next property. Notice I'm just changing color for every property so that you can tell we're changing properties. The identity property says everything stays the same. It's what can we do to something to get back what we had. Stays the same, goes back to itself, right? So when you think of it in terms of addition, you go, well, what can I add to something to get the same thing back? If I have A and I want A back and I'm adding, I go A plus 0 still equals A. Multiplying, I'm thinking the same way. What can I multiply times A and get A back? And the only thing we can multiply something by and get itself back would be 1. So A times 1 equals A. And so in addition, the identity property is just adding 0 to something, right? Because that will be the one thing that we can add and not change it. In multiplication, it's multiplying times 1 because that is the one thing that we can multiply by and not change it. If I have 3 plus 0, I get 3 back. If I have 3 times 1, I get 3 back. And that's what the identity is. It gives us back itself. Stays the same. Our next property is the inverse property. And the inverse property inverse is always kind of an undoing. So we're using the opposite thing to cancel a value. What do I mean by that? I mean, in terms of addition, right? If I have a plus negative a, I get 0, right? I've canceled that out. In terms of multiplication, if I have a times 1 over a, I get a over a, which is just 1. So in this respect, when I'm adding, I'm trying to get 0. When I'm multiplying, I'm trying to get 1. And we're just doing the opposite of what's done to it. The opposite of adding a positive a would be subtracting a from it. If we look at that, if I have 3, its inverse would be negative 3, because that would give me 0. Here, if I have 3 and I want the multiplicative inverse, I'd multiply times 1 over 3, because that would give me 3 over 3, which equals 1. The next property we're going to talk about is the property of 0. And you guys learned this one probably in elementary school. You just didn't call it this, right? Property of 0. Ultimately, we're saying if I multiply by 0, it always equals 0. Anything I multiply by 0 equals 0, right? You guys have known this since elementary school. Notice this one's only multiplicative, but no matter what I multiply by 0, I can multiply 3 times 0, I'm going to get 0. I can multiply 247,312 times 0, and it's still going to equal 0. Anything I multiply by 0 is 0, and it's the 0 product property is what we really call it, but here we're calling it the property of 0. And that will come in really handy down the road mathematically to understand that. And it's something that you guys learned in elementary school. Anytime I multiply by 0, I'm going to have a result of 0. Our next property we're going to talk about is the distributive property. And you guys have probably played with this a little. Distributive property. Right? Well, the distributive property says if you multiply a value to an expression, a value to an expression inside of parentheses, right? This is where you have to multiply it to each part of that parentheses. So if I have a times b plus c, that is going to equal a times b plus a times c. I have to multiply it times the b, and then I also have to multiply it times the c. So if I have, say, 2 times x plus 7, I'm going to multiply 2 times x and get 2x, and then I'm going to multiply 2 times 7, and I'm going to get plus 14, right? If I have negative 5 times y minus z, I'm going to multiply that negative 5 times y, so I'll have negative 5y. Then I also have to multiply negative 5 times negative z and get positive 5z, right? So we have to distribute it to each piece inside that parentheses. And that's what we're talking about when we're talking about distribution. Now we have a couple of what we call the new properties that they're not really new in life, but they're most likely new to you at this point. First of them being the reflexive property. And reflective basically says a value will always equal itself, right? It's a reflection. What does that mean? It means A equals A, B equals B, BC equals BC, right? All of those are true statements, right? 16 equals 16. 112 equals 112. Things will always equal themselves, right? 4y squared equals 4y squared, right? Everything equals itself. So that's a pretty easy one, right? It's always going to come back to itself. What can we say? Well, we can say that 4y squared equals 4y squared. Next, we have the symmetric property. Symmetric means symmetry, right? So something's got to be the same or mirror image. The symmetric property says that if A equals B and B equals C, then B also equals, oh, sorry. If A equals B and B equals A, sorry, I was jumping all the way to the next property, transitive property. If A equals B and B equals A, if A equals B, then B equals A. Sorry, I'll make that prettier. All right. If A equals B, then B also equals A. That's symmetry, right? If A equals B, B equals A. So what does that look like? If X equals 3, then 3 equals X. If X equals 3, then 3 equals X. If 5X equals 30, then 30 equals 5X, right? Here's the one I was jumping to. This tends to be the one that people have the hardest times with, the transitive property. What the transitive property says is if A is equal to B, I usually like to do a different color when I change properties. So let's switch back. So we'll go transitive. It says if A equals B and B equals C, then A equals C. Does that make some sense? I hope so. You can't answer the question because you're a video right now. So what does that say? If 4 plus 3 equals 7 and 7 equals the square root of 49, then 4 plus 3 equals the square root of 49. I'm not going to get into the closure property. I could, but I'm not going to. what I'm going to do is I'm going to put a little quiz here at the end of this video. And this is all I really have for you in terms of this first Ed Puzzle video. It'll be your only assignment. So pay attention to the end. You're going to have a little quiz. It'll be a multiple choice quiz where you're given a scenario and you just have to guess which property it is. So I hope you paid attention to the properties. Please do. Technically, this is like your lesson. You're supposed to be taking notes while you watch it. If you have any questions, feel free to let me know on Thursday during class.